I'm Ma'am Jessa DJ Roque, and today we will be having another discussion in general mathematics. I hope you enjoy today's lesson and activities as we learn to love mathematics. But before we proceed with our discussion for today, let us first have our objectives, which will be our target at the end of this lesson. First, we will learn how to evaluate functions given the value of the variable. Next is to perform addition, subtraction, multiplication, and division on functions. Lastly, we will compute the composition of functions. I hope you will learn a lot in our discussion for today. Since we are aware of our target for today, let us first have a simple game which I know you are very much familiar with. This is 4-peat 1 word. So for our question for today, you have 30 seconds to answer the given item. Time's up! Very good! Our answer for today for this question is function. Good job! Aside from the definition of functions, there are also several concepts underlying it. One of these is the operations on functions. We have the sum, which is defined as f plus g of x is equal to f of x plus g of x. The difference, which is f minus g of x, is equal to f of x minus g of x. The third, which is the product, is defined as f times g of x, which is equivalent to f of x times g of x. And the last, which is quotient, f divided by g of x is equivalent to f of x to be divided by g of x. For this part, we have to denote that g of should not be equal to 0. To help us understand these definitions, let us try the following examples. For our example number 1, we have f of x is equal to 5x squared minus 2x minus 9, and g of x, which is equal to 2x cubed minus x squared plus 6x minus 3. We are asked to find f plus g of x. For our step 1, we should apply the definition in adding functions. That is, f plus g of x is equal to f of x plus g of x. Substituting the given values, we have f plus g of x is equal to 5x squared minus 2x minus 9 plus 2x cubed minus x squared plus 6x minus 3. For our second step, we're asked to group similar terms and arrange them in descending order with respect to their exponents. From where we stopped from the previous slide, we had 5x squared minus 2x minus 9 plus 2x cubed minus x squared plus 6x minus 3. Based from the given step, we're going to group similar terms. 2x cubed plus the group 5x squared minus x squared. Then the next group, negative 2x plus 6 plus the last group, which will be negative 9 minus 3. We will now proceed with the last step, which is to combine similar terms by performing the operations indicated. Combining those different groups, our final answer will be f plus g of x is equal to 2x cubed plus 4x squared plus 4x minus 12. To understand the concept better, Let us have the next example. The given are f of x is equal to x squared plus 4x plus 13 and g of x is equal to negative 6x squared plus 10x minus 13. We're going to find f minus g of x. For our first step, we're going to apply the definition in subtracting functions, which is f minus g of x is equal to f of x minus g of x. We substitute the given values. We have x squared plus 4x plus 13 minus the quantity negative 6x squared plus 10x minus 13. To be followed by the second step, which is to group similar terms and arrange them in descending order with respect to their exponents. For that step, we're going to group them according to their exponents. The first group will be x squared plus 6x squared. The second group will be 4x and negative 10x. The last group will be 13 plus 13. For the last step, we combine similar terms by performing the operations indicated. As we group the given terms, we're going to observe the subtraction sign. That is why the subtrahend symbol will be changed. So the final answer will be f minus g of x is equal to 7x squared minus 6x plus 26. Let us have example number 3. The given is f of x is equal to 5 over x squared minus 1 and g of x is equal to 2x all over x minus 1. We're going to find f plus g of x. Similar with the previous examples, the first one is to apply the definition in adding functions. So we substitute the given values. It will be f plus g of x is equal to 5 over x squared minus 1 plus 2x all over x minus 1. For our second step, we're going to find the LCD of x squared minus 1 and x minus 1. The LCD will be x minus 1 multiplied by the quantity x plus 1 or x squared minus 1. Applying it in the given example, f plus g of x will now be equivalent to 5 plus 2x to be multiplied to the quantity x plus 1 all over the product of x plus 1 and x minus 1. For the last step, we have to simplify the given expression. Simplifying it, we have to multiply 2x to the quantity x plus 1, so the final answer will be equivalent to 2x squared plus 2x plus 5 all over the quantity x plus 1 to be multiplied to the quantity x minus 1. For the numerator, we're going to observe the degree of their exponents. To proceed with the next example, our given is f of x is equal to x cubed minus 27, g of x is equal to x squared plus 3x plus 9, and h of x is equal to 4x minus 1. We're going to find f times h of x. For our first step, we're going to apply the definition in multiplying functions, which is f times h of x is equal to f of x times h of x. We substitute the given values. It will become x cubed minus 27 will be multiplied to 4x minus 1. The next step is to multiply the two expressions using distributive property and combine similar terms. If we will be multiplying the given terms, it will result to 4x raised to 4 minus x cubed minus 108x plus 27. For the last example under operations on functions, let us have example number 5. The given is f of x is equal to x cubed minus 27, g of x is equal to x squared plus 3x plus 9, and h of x is equal to 4x minus 1. We're going to find f divided by g of x. Similar with the previous examples, for the step number 1, we're going to apply the definition in dividing functions. And that definition is f over g of x is equivalent to f of x to be divided by g of x. Now we substitute the given values, it will become x cubed minus 27 to be divided by x squared plus 3x plus 9. For the second step, we're going to factor both numerator and denominator if possible. Since the numerator is factorable, we will be factoring it out and become x minus 3 multiplied by the other factor, which is x squared plus 3x plus 9, all over the denominator, which is x squared plus 3x plus 9. And for the last step, we're going to cancel common factors and simplify the remaining terms. Since the other factor of the numerator is similar with the denominator, which is x squared plus 3x plus 9, we're going to cancel them out, so the final answer will be equivalent to x minus 3. Aside from the operations on functions, we also have the composition of functions. This composition of functions is defined by f of g of x, which is equivalent to f of g of x, where the domain of f of g of x is the set of all numbers x in the domain of g of x, such that g of x is the domain of f of x. For our first example under composition of functions, our given is f of x is equal to x squared plus 2 and g of x is equal to 6x minus 3. We're going to find f of g of x. Our first step is to apply the definition in composition of functions. From the definition, we're going to get g of x as the domain of the function f. So that will become f of 6x minus 3. We continue with step number 2. We apply the definition of f. So given that f of 6x minus 3, it will become 6x minus 3 quantity squared plus 2. 6x minus 3 is substituted as the value of x in the function f. To continue with step number 3, we have to simplify. We will be simplifying the quantity square of 6x minus 3, which will become 36x squared minus 36x plus 9, then continue with plus 2 at the last part of the given equation. And to have the final answer, we perform the operation and it will be 36x squared minus 36x plus 11. To proceed with the next example, our given is f of x is equal to x squared plus 2 and g of x is equal to 6x minus 3. This time, we will be looking for g of x. As the first 1, 2, based from the first step, we apply the definition in composition of functions. This time, our domain will be g of x, which is equivalent to 6x minus 3. As we apply the definition of g, the variable x from the given function g of x will become 6x minus 3. So it will be 6 multiplied by the quantity 6x minus 3 minus 3. And to simplify for the last step, we're going to distribute 6 to the parenthesis 6x minus 3. So that will result to 36x minus 18 minus 3. And for the last, we have to combine like terms to get the final answer, which will be equivalent to 36x minus 21. Example number 8, we have f of x is equal to x cubed, g of x is equal to 7x plus 9, and h of x is equal to 10x minus 17. This time, we're going to look for f of g of 2. First, we apply the definition in composition of functions. We will be looking for f of g of 2. The domain g of x will have a value of 2 for the variable x. So we evaluate the definition of g by substituting 2 to the variable x of the function g of x. So 7 multiplied by 2 plus 9. Simplifying, g of 2 will be equivalent to 23. For our next step, we have to apply the definition of f. Since we already solved for g of 2, which will be equivalent to 23, we will now be using that 23 as the value of the variable x in the function f, which will be x cubed. So as to substitute, it will become 23 cubed. Solving for it, it will be 12,167. And for our last example, we have the given f of x is equal to x cubed, g of x is equal to 7x plus 9, and h of x is equal to 10x minus 17. We have to find g of h of negative 1. The first thing we're going to do is to apply the definition in composition of functions. So that is g of h of negative 1. Our domain is h of x. So we have to evaluate the definition of h by substituting negative 1 to the variable x of the function h. So that will be 10 multiplied by negative 1 minus 17. Evaluating, it will result to negative 27. This time, we're going to apply the definition of g. By using negative 27 as the value of x to be substituted to the function g, we have 7 multiplied by negative 27 plus 9. Our final answer will result to negative 180. Okay, so after all those steps and solving, let us have a simple recap of our discussion for today. Always remember that for operations on functions, we have sum, which is f plus g of x is equal to f of x plus g of x. Difference, which is f minus g of x is equal to f of x minus g of x. The product, which is defined as f times g of x is equal to f of x times g of x. And the last, which is the quotient, which is defined as f over g of x is equal to f of x divided by g of x, where g of x should not be equal to 0. And to complete the discussion, the composition of function which is defined as f of g of x is equal to f of g of x, where g of x is the domain of the function f. Good job! At this point in time, it is now your turn to try solving the given items on your own. In this activity, You are given several functions and you are asked to perform the indicated operations involving functions. Great! After completing the previous activity, here is an exciting challenge for you. You have to solve each question that corresponds to every letter, then look for the message that answers the question, why is the river rich? You're allowed to work collaboratively with your classmates and encouraged to send your ideas to your teacher. That sums up our lesson for today. I hope you enjoyed the discussion with me as well as every activity given. Just a simple reminder, I will be leaving you a quotation from Paul Valéry saying, "The best way to make your dreams come true is to wake up." Again, this is Ma'am Jessa Roque saying thank you and have a good day ahead.